Unit 10, Formative 3. Match the following equations with their appropriate graph. For the one graph you have left over, explain how you knew it did not match any of the equations given. So, probably the easiest way to do this is to jot down the key features that are easy to find from each form. So when I look at the equation in number 1, that is factored form. It's two sets of parentheses being multiplied together, nothing's being squared. So that's factored form. So when you're in factored form, you can easily identify the concavity from the a value. So the a value is -1, which means that the graph is concave down. So I'm going to do CC for concave and then the arrow pointing down. Then, from factored form, your numbers in your parentheses are your R values. And the generic factored form equation is this right here. So a times x minus r sub 1, and then x minus r sub 2. So those r sub 1 and r sub 2 values, those are your x-intercepts, or your roots. So since there are built-in minus signs in the generic formula right here, it means that we want to take the opposite of the numbers we see in the parentheses to get our x-intercepts. So our x-intercepts would be -2, 0, and -6, 0. So then let's just look at our graphs and see which one goes down and has an x-intercept at -2, 0, and -6, 0. So right here, option B, you're concave down and you have the correct x-intercepts. So that one's gone. On number 2, that is vertex form. Okay, vertex form. So vertex form looks like this. So a times x minus h squared plus k, where the a value tells you your concavity. So since a is 1, we're going to be concave up. And then the h and the k are the vertex. Since there's that built-in minus sign right here, we want to take the opposite of the number in parentheses for the x coordinate of our vertex. So 3, -1 for our vertex, because HK is going to be the vertex. So now we're looking at our graphs. We want it to be concave up with a vertex at 3, -1. There it is. So option E right there. Vertex is 3, -1, and we're concave up. So option E. On number 3, this is standard form. So standard form looks like this, ax squared plus bx plus c, where the a value still tells us our concavity. So a is -1, so we're concave down. And then the c value is going to be our y-intercept. So -3 will be our y-intercept. So we want a graph that is opening down with a y-intercept at -3. So I'm looking up at option A, or graph A. Here's my y-intercept at 0, -3, and it is concave down. On number 4, we're in vertex form again. So a value is a half, which is positive. So we're looking for a concave up graph. And then our vertex is going to be HK. So the opposite of the number in the parentheses, and then it matches the number in the back. So let's see here. Hopefully C works, because D looks like it doesn't work. Yep, there we go. Vertex at 4, -2, and it's concave up. So C works. So the graph I had left over was D. I know that this one does not match any of the above equations because, well, there's obviously the answer of it was the only one left, but to be a little bit more descriptive and a little bit more specific, maybe I can just mention the key features from graph D and say that that didn't match any of the equations. So when I look at graph D, we have a vertex at -1, 1. We have an x-intercept at 0, 0, and -2, 0, and we're concave down. Oh, and our y-intercept would be 0, 0 as well. So I'll just say none of the equations had the following key features. So we had x-intercept of 0, 0, and -2, 0. Vertex -1, 1. Y-intercept of 0, 0, and concave down. Number 6, solve. So when we have quadratic equations with x squared terms and x terms, we want to make sure everything's on one side equal to 0. And then we try to factor, set each factor equal to 0, solve for x. So this one, everything's already on one side. So we're going to try to factor. No GCF other than 1, and it's a trinomial, and there's an a value other than 1. So we need to do advanced factoring. So remember, this is a, b, and c. So we want two numbers that multiply to a times c and then add up to b. So 5 times -4 is -20, and then b is -8. Just for the sake of time, I'm just going to jump to the two numbers that actually work. Since we spent so much time on factoring on the last formative, should be pretty decent at it by now. So let's see here, -10 and 2, I think. Let me check. So -10 times 2 is -20. -10 plus 2 is -8. So yep, that works. So I want to split the -8x into -10x and 2x. And then I want to drag down the 5x squared in the front, drag down the -4 in the back. And then technically, let me squeeze in an equals 0 here, just to remind ourselves that this is an equation that we're solving. And then I want to do factor by grouping. So group your first two terms, group your second two terms. I'm going to factor out my GCF from the first two terms. So divide out of 5x. Leftovers are x minus 2. And then in the back set of parentheses, divide out a GCF of 2. Leftovers in the back are x minus 2. Let me drag down that equals 0 before I forget that we're solving an equation. And then I'm going to take that purple x minus 2 and factor it out in the front. Green 5x plus 2 in the back equals 0. So at this point, we've factored, so we want to set each factor equal to 0 and solve for x. So x minus 2 equals 0, 5x plus 2 equals 0, and then you just do normal equation solving. So that first equation is really, really short. It's just a one-step equation. And then that second equation is a little bit longer. I think it's 2 steps. So divide by 5, divide by 5. So x equals -2/5, and x equals 2. On 7, they want us to algebraically find the x-intercepts of f of x equals x squared minus 3x minus 4. So if you are on the x-axis of any graph, so like here, your y-coordinate has to be 0. So we're going to let f of x equal 0. Once you get past that point, this problem becomes just like number 6. So I'm going to try to factor. We're in luck because this is a basic trinomial instead of an advanced one because the a value is 1. So I'm looking for two numbers that multiply to -4 and then add to -3. So -4 times 1 is -4, and then -4 plus 1 is -3. So I get to just jump straight to my answer when it's a basic trinomial, as opposed to doing all the craziness we did on number 6 for the advanced factoring for the trinomial when the a value wasn't 1. So we factored, set each factor equal to 0, solve for x. So we have 4 and -1. The way this question is asked, let's write our final answers as the actual ordered pairs, because it wasn't just asking us to solve, it was asking us to find the x-intercepts. So let's actually say the coordinates of the x-intercepts. On 8, we want the vertex of that equation. So remember, this is in standard form, so here's a, b, and c. In order to find the vertex, you do x equals negative b over 2a. That's a formula that you need to memorize. You just have to know that off the top of your head. So negative 12 over 2 times 3, and then you just simplify that down to negative 2. And then now that you know your x value, plug negative 2 back in for x in the original equation. So 3 times negative 2 squared plus 12 times negative 2 minus 8. The one thing people love to mess up, they try to do 3 times negative 2 before negative 2 squared. Okay, you have to do the negative 2 squared equals 4 first. Otherwise, you're violating order of operations. And then from here, it should be pretty straightforward. So 12 minus 24 is negative 12. And then negative 12 minus 8 is negative 20. At the very end, we are trying to find a vertex. So write your final answer, x comma y. So here's my x, here's my y. Last one, determine the y-intercept of f of x equals 2x squared minus 10x plus 8. Love it. If you are in standard form, your c value is always your y-intercept. So 0, 8, done. You technically don't have to show any work. If you're someone who needs to kind of know, like, why does that work again? Here's why. If I'm anywhere on a y-axis, I haven't moved left, I haven't moved right, so x has to be 0. So then back over here, if I plug 0 in for x like this, and then I actually simplify, everything cancels. Right, 0 squared is 0. 2 times 0 is 0. So all that's left is 8. So either way you think about it, you get the right answer.